Hello and welcome to our webinar. This lesson is about zero product property, and this is to be watched before 5/13, Friday the 13th. Alright, so the first thing we're going to do is we're going to talk about matching quadratics, and we're basically trying to put together all the factoring and all the multiplying together that we have done and try to make it so that we can see what we're getting, and so the solutions. So we're trying to figure out solutions. So the first thing I want to do is figure out what the solutions are for each one of these graphs. And you'll notice that this graph up here is positive 4, negative 4 is where it's crossing the x-axis. Those are solutions. This one down here looks like it is at negative 5, positive 5, so I'm going to put that one there. And this one looks like it is at positive 3, negative 3. And so now we need to find out what equation would give me that. Well, hopefully you notice that this is a U-shaped graph. So it is, just by process of elimination, I can say, oh, well, this one is a U-shaped graph that has moved down 9 units. So that would have to be this one, because look, it's crossing down here 9 units down, just remembering our transformations from before. This one over here, this one up here is moved, the U-shaped graph moves 16 units down. So that should match. And then last but not least, the graph has moved 50 units down, and so that's what we're looking at. And it's a little narrower graph because we're multiplying by 2. So all of this you could have done with the transformations, and that's basically what we're going to be doing today. So what is the zero product property? Well, what it means is if we take A times B, then it has to equal 0. And so either A is 0 or B is 0. Could they both equal 0? Yeah, they could. So we're just trying to figure out, and that's how we're going to be solving these. We're going to be finding out, we're going to use that to find out where we're crossing the x-axis. So remember, all of this stuff that we're doing today is based on where does it cross the x-axis. So this one, if we want to find the solutions, what y is, we just say, well, a, which is y plus 9, could be equal to 0, or y minus 1 could equal 0. Now if I solve this little algebraic problem by subtracting 9 across the equal sign, then y is equal to negative 9. That's one place the graph would cross the graph. And then the one down here, if I add 1, then the final solution would be y equals positive 1. So the graph of this equation would cross at negative 9 and positive 1. So then this one, same thing, we just say z minus 13 equals 0, or z minus 14 equals 0. And so if I solve these, I add 13 across the equal sign, and in this case I end up with z equaling 13, and this one down here we will add 14 across the equal sign. So then z will equal 14. So these are 13 and 14 is where the graph is crossing the equal sign. Doesn't matter if it's a decimal or a fraction in there. No, not at all. So g minus 0.75 will equal 0, and g plus 18 will equal 0. If I add 0.75 across the equal sign, then g is equal to, and it probably should have a 0, 0.75. In this case down here, if I subtract 18 across the equal sign, g will equal negative 18. So that's what the zero product property is all about. So our goal is we're going to have to factor things to get to this part, and then we set it equal to 0. So then how do we solve this without graphing? Well, like I just said, we're going to factor this. So you need to remember from the previous one that we set up an x box, we take 1 times 9, and we get 9, and then we need those two factors to add together to get me positive 6. So I need to think of the factors of 9. Well, 9 is either 1 times 9 or 3 times 3. Well, we need 6 down here, so 3 and 3 are my factors. So in this case, if I say x plus 3 times x plus 3 equals 0, then those are my factors. Now you'll notice in this case that if I say x plus 3 equals 0 and x plus 3 equals 0, I'm going to get the same solution twice by subtracting 3 across the equal sign. I'm going to do it for both of them since I'm doing the same thing. Then x will equal negative 3 for both of them. What does that mean graphically? Well, if I was to graph this, what would happen is it would be a parabola that would touch the graph back here. It wouldn't cross, it would just touch at negative 3. And so that's really what happens when we get the same thing twice. The graph doesn't cross, it touches. When we get two different numbers, the graph would do something like this and cross twice, and we're looking for those two solutions. So then, if we're going to use the zero product property for this one, we're going to factor it, and then we'll solve it. This one we're going to end up graphing in just a second. So this one, x squared minus 4, well, if I set up my x box, I have negative 4 at the top and 0 at the bottom. So I need to come up with the factors of negative 4. That will give me, so it's either negative 1 times 4, negative 4 times 1, negative 2 times 2, and I can flip them around, but those are the ones I want, negative 2 and 2. So now my factors come out to be x minus 2, x plus 2. Now you'll notice that in this, and this is like all algebra, basically we teach you one step, we taught you factoring yesterday, now we're taking it up a step, and we're teaching you how to use what the factoring you did. It's useful. So now I use my zero product property. Zero product property says set each factor equal to 0. And solve. Well, if I add 2 up here, I end up with x equaling 2. If I subtract 2 down here, then x would equal negative 2. And actually, I'm going to use this graph over here to show you this, and I'll graph this one in red. It says, looking at my transformation from before, I know this graph is U-shaped, and it's going to cross down here at negative 4. With that, then I know it has to cross at positive 2 and negative 2, because that's what we just did with the zero product property. So that graph would look something like this. And so you can see that when I graph it, I'll end up with the same thing. It's just giving me the graph, the zero product property without graphing gives me the solutions to where the graph is crossing the x-axis. So does it work on something like this up here? Let's try it. Well, again, I multiply the first and last term, I get positive 6. I need it to be 5, and I need the terms to add to get me 5. So I have 2 times 3 or 1 times 6. Those are my factors of 6. And 2 and 3 will add to get me 5. So in this case, my factoring becomes x plus 2, x plus 3, and I set it equal to 0. Which means I break them apart and say x plus 2 equals 0, x plus 3 equals 0, and then I solve, subtract 2. So in this case, x is negative 2, and I will add, subtract 3. So I end up with x equaling negative 3. And so my two solutions for this one, let me get rid of it, my two solutions are basically going to be negative 2 and negative 3, where the graph is crossing the x-axis. And the question then is, how the rest of this graph going to look? Well, if I was doing this, I would probably plot some points, and the graph is going to be fairly narrow in this case. Basically, the graph is only going to go down probably to a point right there, and it's going to do something like that. And we could figure it out pretty darn quick with where the graph is going and how far down it goes by graphing it on a graphing calculator or just plotting points. Alright, so moving along here. Alright, so then we wanted to go the other way. This time I'm giving you where it's crossing the x-axis, negative 3 and 5, and I want you to write the equation. Well, if I give you negative 3 and 5, then I would set it up to look like this. Then using FOIL, I would end up multiplying together, and either one of these equations would work. So try each one of these on your own. And so if I do the next one, it would be something that looks like that. Oops, we got those backwards. That one should be positive 4. Oh, no, I did it right. That's right. I'm sorry, it's right. You'll notice that the signs switch when I put these in. So negative 4, because remember, you got to set them equal to 0 and add them across. And so then the next one, when we multiply it out, will look like that. If you switch the signs up, then you'll end up having some issues, and it'll give you the wrong answer. So just be careful on that. We'll talk more about that. So then here's our out. So they want you to find the zeros where the graph is crossing. And the first one, I can basically say x minus 3 equals 0, and 2x plus minus 2 equals 0. And if I solve each one of those, I'm going to add 3. So x equals 3. And if I add 2, I end up with 2x equals 2, divide by 2, x equals 1. Those would be my two solutions where the graph is crossing. The next one you'd have to factor. We have to factor 24 to get 10. Well, 24 factors to 6 times 4. That's one of them. There's plenty other ones, but those are the ones we're going to use. So it's going to be x minus 6 and x minus 4 plus and plus. Sorry, x plus 6, x plus 4 is our factors, and they set those equal to 0. So the places where our graph crosses would end up being, with a little bit of algebra, x equals -6 and x equals -4. Alright, so we'll do a little bit more of this. Hope you guys have enjoyed this webinar. I will talk to you guys soon.